In the diagram, D and E are the midpoints of A, B, and B, C respectively. Determine the equation of the line passing through the points C and D. So C would have the coordinates 8, 0, and D would have the coordinates 0, 3. So your standard y equals mx plus b equation, where m is the slope. And you guys have done this a million times. So this is 3 minus 0. 0 minus 8, and that is negative 3 over 8. So therefore, y is equal to minus 3 over 8, x plus b. Sub any of these points to get b. I'll just sub in this one. So that means 3 is equal to b, and therefore the final equation is y is equal to minus 3 over 8, x plus 3. Part B, determine the coordinates of f. Okay, in order to get the coordinates of f, we need the equation for the other line, which is AE. So line AE, that line. Now, I just did this line, which is, what was this? This was line CD, right? Yeah. So it's the exact same thing. So I'm not going to do it again. I'll let you guys do it. You certainly should know how to find the equation of a line. And when you do, you get y is equal to minus 3 over 2x plus 6. In the same way that I did it here. Okay, nothing special. And then to find the coordinates, you just set these two equal to each other. So that means minus 3 over x plus 3 is equal to minus 3 over 2x plus 6. So when you solve for this, you get x is equal to 8 over 3. And then to get y, you can substitute it back into this or this, either one, and you get y equals equal to 2. So the coordinates for f are 8 over 3 and 2. Determine the area of triangle DBC. DBC. Okay, so this guy right here. Okay, well that's pretty easy. That's just 1/2 base times height. The base is 8 and the height is 4, right? No, so the height is 3. The height is 3 because it's half of 6. So that's going to be 12. And then finally, determine the area of the quadrilateral DBEF. DBEF. Okay, so what I'm going to do is I'm going to cut it in half, and each of those sections will be equal. See, DBEF, if you cut it in half like that, this part is the same as this part, right? It's symmetric. So all I have to do is just find the area of one of those. So the area will be 2 times those, and each of those is a triangle, so 1/2 base times height. Base times height. The base from here to here looks like 4, since E is the midpoint. And the height from here to here is the y coordinate of f, which is 2. So that just becomes 8. And that's it. A set S consists of all 2-digit numbers such that no number contains a digit of 0 or 9, and no number is a multiple of 11. Determine how many numbers in S have a 3 as their tens digit. All right. So there's 2 digits, right? The first one, they want a 3. So there's one choice there. For the second digit, we can have a 1, 2, a 3, a 4, a 5, a 6, a 7, or an 8. You cannot have a 9. So that means there's 8 choices there. So 1 times 8 is 8. Okay, now we're not done though, because remember, you can't have a multiple of 11. One of the multiples of 11 is 33. So that number has to be subtracted from that 8. So instead of 8, you got to get rid of that 33, so there's only 7 remaining. Part B, determine how many numbers in S have an 8 as their ones digit. Okay, so same kind of story. This ones digit is going to be an 8, so that's one choice. This tens digit can be a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8, right? So that's 8 choices. So again, it's an 8 times 1 scenario. But again, we have to get rid of a multiple of 11, and in this case, that would be 88. That multiple of 11 has to be subtracted from that 8. So it's actually 8 minus 1, which is 7 again. How many numbers are there in S? Okay. Well, again, you have 2 numbers. The first number can be a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8. So you have 8 choices there. The second number can be same thing, 1, 2, 3, 4, 5, 6, 7, or 8. So we have 8 choices there. And therefore that's 64. But however, we can't have we cannot have any multiple of 11. So I have to get rid of 11, 12, 13, 14. Oops, sorry, what am I doing? Multiples of 11 are 11, 22, 33, 44, 55, 66, 77, 88. There's 99, but 99 is not going to be part of this because there's no 9. So of the 64, we have to get rid of these 8 guys. And when we do, that leaves me with 56. So 56 is the answer to part C. Determine the sum of all numbers in S. Okay, this is a little bit more complicated here. All right, so first of all, there's 2-digit numbers, right? So if I had all 2-digit numbers, it would be 10 plus 11 plus 12, blah, 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 all the way till 99, right? So this sum is basically S99 minus S9. Now, those of you who didn't understand what I just did there, you guys remember 1 plus 2 plus 3 plus ... all the way till n is given by that formula n times n plus 1 over 2. And this is what I'm referring to. This is sort of the S at n. So we want to add up all the numbers, not from 1 to 99, from 10 to 99. So I've got to add up all the numbers from 1 to 99, and then I have to subtract the 1 to 9. That's why it's S99 minus S9. So this is 99 times 100 divided by 2 minus 9 times 10 divided by 2. And this, when you crunch out these numbers, is 4905. Okay. But that's not S, right? That's not even close to S. This is all the numbers from 10 to 99. We have to get rid of a bunch of numbers because remember, we only have 56 numbers in S. So let's do this in a systematic way. The total number that of numbers, total number of numbers. So let's just write here numbers. How many? Well, all of these guys from 10 to 99 would represent 90 numbers, right? But we don't want the sum of those 90 numbers. We want sum of just 56 numbers that are part of S. So we've got to get rid of 90 minus 56, which is what? 34 numbers. Okay, so we got to first we have to figure out what those 34 numbers are, and then we got to get rid of them from this sum. Okay, so let's do that. Let's figure this out. Okay, well, the first thing is we got to get rid of all the multiples of 11. So 11, 22, 33, 44, 55, 66, 77, 88, and 99. Okay, so these guys, this is what, how many? This is 9. So these guys we have to get rid of. Adding these all up, it's really just, if you factor out the 11, you can just, it's really just the sum from 1 to 9, and this can easily be calculated. 11 times 45, I believe. Yeah, so that's 495. All right, so that's pretty good. Okay, now we still have about, let's see here, 25 numbers more that I got to get rid of from everything to end up with the set S. Okay, well, what were the rules? We can't have a 0, so I can't have the 10, 20, 30, 40, 50, 60, 70, 80, 90. These numbers we cannot include, so that is, how many is that? That's 9 numbers, right? Okay, so those 9 numbers. And the sum, we can just add those up. That's pretty straightforward. It's going to be 450. That's the sum. Okay, so that sum I got to get rid of. Then I can't have a 9 in the number. So all the 9s from 90, 91, 92, all the way to 99, those ones I can't have also, because that's part of the rules. And this is an additional 10 numbers. Yeah, 10 numbers. Okay, and then I cannot have a 9 as the ones digit either. So I can't have 19, 29, 39, and so on. 49, 59, 69, 79, 89, or 99. And that's what, 9 numbers? Yeah, 9 numbers. Okay, now this sum right here, all of these guys, you can add those up pretty quickly. 90 to 99, right? Oh, but here's the thing. Before I add them up, I got to get rid of doubles. There's overcounts here. Yeah, because notice 9 plus 10 plus 9 is 28. but we only need 25. So there's 3 numbers that I've overcounted. And I'll show you which ones. Let's see here. Up here we had a 99. So any 99 we've double counted. So we got to get rid of those 2. And then let's see, any other double counts? Yeah, this 90 is counted twice. So I got to get rid of one of them. So that makes sense. So this 28, you subtract from it these 3 guys. And that's how you end up with this 25. Okay, got it. Okay, so now let's add this up. So this is really what I'm adding, just 91 to 98. And when you do that, 756. And then I add up these guys, but all the way just to 89. And when you do that's 432. All right, so now finally we can figure this out. You take that 4905, subtract from it this 495, subtract from that this 450, this 756, and finally this 432. And when you do, you get 2772. So that is the sum of all the numbers in S. Positive integers x, y, z form a Trenti triple if 3x is equal to 5y is equal to 2z. Determine the values of y and z in the Trenti triple 50yz. 50y and z. So, according to this very important equations, 3x is equal to 5y. So 3 times 50 in this case, x is 50, is 5y. So solving, we get y is equal to 30. And then similarly, 3x is equal to 2z up there. So that means 3 times 50 is equal to 2z. And solving this, we get z is equal to 75. So our Trenti triple is 50, 30, 75. So that takes care of part A. Part B, show that for every Trenti triple, x, y, z, y must be divisible by 6. So 3x is equal to 5y, correct? So that means that y is a multiple of 3, right? Because 3 times something is equal to 5y. Now 5 is not a multiple of 3, so y must be a multiple of 3. And then similarly, we know that 5y is equal to 2z. Now that immediately tells you that y is an even number, because 5 is not even, and if it's even, then it's a multiple of 2. So y is a multiple of 2. So now you just combine these. It's a multiple of 3, it's a multiple of 2, so therefore y is a multiple of 3 times 2, which is 6. And that's exactly what they wanted you to do. And finally, the product xyz must be divisible by 900. Okay, so it's pretty much the same story. In this part B, you showed that y is a multiple of 6, right? So that's very important. Now we have to show what x is a multiple of and z is a multiple of. And then that way we can combine them to find out what is x times y times z a multiple of. Got it? Okay, so it's the same kind of story. Nothing fancy. From our equation, we know that 3x is equal to 5y. So that means that x is a multiple of 5, right? And similarly, 3x is equal to 2z. So x is a multiple of 2. Combining 2 and 5, we get that x is a multiple of 10. And in a very similar way, we talk about z. 3x is equal to 2z. So z is a multiple of 3. And similarly, 5y is equal to 2z. So z is a multiple of 5. Combining 5 and 3, z is a multiple of 3 times 5, which is 15. So therefore, xyz will be a multiple of the 6 times a multiple of 10 times a multiple of 15. And 6 times 10 times 15 is 900. So there you go. We just proved that xyz is going to be a multiple of 900, therefore it's divisible by 900. Let f at n represent the number of ways that a positive integer n can be written as the sum of positive integers, positive odd integers. For example, f at 5 is 3 and f at 6 is 4. Find f at 8 and list all the ways that 8 can be written as the sum of positive odd integers. Okay, so 8 can be written as a sum of just ones, right? 1 plus 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 1. Or you can add 5 of these ones and then a 3. Or you can add just 3 of these ones, 1 plus 1 plus 1 plus a 5. Or just 1 and a 7. And then there's a couple other ways. You can do a 3 plus 5, or you can do a 1 plus 1 plus a 3 plus a 3. So this is 1, 2, 3, 6 ways. So therefore f at 8 is equal to 6.